Hello, everybody. Welcome to math class. So this is just a review class. We have a lot to cover, and I won't cover all of it because there's way too much practice. Honestly, the one thing I want you to remember is that I could do 100 problems and it wouldn't be enough, really, because it's about you doing the practice. So what I would recommend, and I've put all the practice I could find all in one place on the front of the page on D2L. There's actually 7 different practices. There's 6 here. That covers pretty much all the different types of problems in the 3 units. What I would recommend is that you just go in and make sure you can do kind of each type. You kind of get an idea of what the types are, right? Like there's probably 5 different questions that ask you to change from polar form to rectangular form. So if you know how to do 1 or 2, you can probably do the rest. So you can pick and choose which problems you want to do. But there's more than enough for you. If you can't do word problems, make sure you go and you can do every single word problem in the book, because that's the only way to get better, right? That kind of thing. So let me go through what I think are the most important pieces. First of all, I'm going to go through these practices today. If you haven't downloaded them or have them available, well, that's okay, because I'm going to go through them and you'll have this video later, but make sure you try to get it in front of you. It's very good practice. And that's over and above what's already in the book, the course notes. So there's almost too much practice in this course. So you shouldn't have a problem practicing. I want to go through the most important pieces of the test, okay? I'm going to try to make as clear as I possibly can. Test is tomorrow. It's during class time. So for you, that would mean when exactly. So tomorrow, class is at, for you, 2:10. So the class and the test starts at 2:10, okay? Got that note on? I saw your question. 2:10. What that means is there are 2 pieces. There is a multiple choice piece. It will be a D2L quiz. There is a Dropbox piece, which is a Dropbox file, like your assignments, okay? When you start the class, open both. Open the D2L quiz, and then in another tab or something, open the Dropbox. Or you can open the Dropbox, print it, or have it ready, have those questions ready in front of you, and then you can open the D2L quiz. I don't care how you do it, but what's important is when you first start, you've got to do the multiple choice and you've got to do the Dropbox section. Okay, the reason it's in 2 pieces, and you'll see this here, 10 multiple choice, they're accessed as a D2L quiz. It closes after 1 hour. Let me just focus on this section here, okay? 10 multiple choice, accessed as a D2L quiz, closes after 1 hour. So as soon as you open that quiz, you have 60 minutes to finish that section. It will not take 60 minutes. It should take 10 or 15. They're not long questions. It's 10 one-mark questions. So make sure that you have to open the multiple choice section within 20 minutes of the class time starting, because it's only open for that time. If you try to access it after 20 minutes, it's no longer open. Once you've gotten into it, it's open for an hour, okay? So as long as you go into the quiz within the first 10 or 15 minutes, you have no trouble. I just want to be clear, you have to open that multiple choice. The Dropbox will be open the entire time up until 1 hour and 40 minutes from the start, okay? So just make sure you have those 2 pieces. I'm trying to repeat myself over and over so you don't forget. Multiple choice, D2L quiz, open it when you start the class. Do them. Dropbox, long answer questions. Submit them all by 1 hour and 40 minutes. Really, 1 hour and a half would be better, okay? Multiple choice, you don't need to do workings. It's either you get it or you don't. Long answer questions, of course you need to do workings like your assignment, okay? So submit those back to the book. And that's the big idea. Do you have any questions before I get into the actual review questions? This would be the time to ask me. Tomorrow during class is not the time to ask me how you get to the test. It should hopefully be clear. If you open the quiz and you open the Dropbox and you're working on the quiz and you're working on the Dropbox thing, you got it, okay? You shouldn't have any issue. I worry sometimes that students are going to be confused. All clear? Digital thumbs up? I'll just take Ahmed's no as everybody's. I hope you're all okay, and alive over there. I hope you're not going back to sleep right now. Some students do that to me. They just sign in and then they're just asleep in bed and keep the computer on. Can't help that. All right, let's get to it. Let's do this. If you have other specific questions, just let me know. There are 6 practice sets that I put on D2L. I hope you've already looked at them. If not, well, I can't make you do anything. And there's also extra practice that I gave of word problems I actually haven't given. I made it last night. I didn't have time to post it. But I want to make sure we can cover those, okay? So first things first, I'm going to jump to the Unit 3 review. And the reason I want to jump to that, it's also called Test 2 review, but that's because it's just labeled differently inside. It used to be a Test 2 review for you guys as a Unit 3 review, whatever. The important thing is the questions. I want you to make sure you can find the equation of something given information, because on your assignment, you were terrible at that. So I want to make sure you can find the equation, all right? So let's go ahead and do that. This questions 2, 9, and 10 are pretty good for that. So right now, what is the parabola's equation with a vertex of -5, -4, and a directrix at y equals 1? So some of you might look at this and be like, oh God, this again. Well, let me show you how I do it. Make a sketch. -4, -5, and 4. 1, 3, 4, 5. 1, 2, 3, 4. So my vertex is right here. The directrix is the line y equals 1, which means that the y values on that line are always 1. So that's my directrix. And the parabola is like scared of the directrix. It always goes away from it. So it's telling you a lot of information. We know the parabola needs to go down like this now. So that tells us 2 things. It tells us that we have a negative p when we get it, but more importantly, we know that this is now x squared form because it's like sad face style, right? So if I need to get the equation, I need to know what the form is going to be. So I need to write out this. And you can look at the formula sheet to figure it out. This is the form for an x squared parabola. We know that because it's got the square root and the x. By the way, students in the other class were asking me, where's the formula sheet? If you go under content in D2L, you hit content, you go to course information, and you go scroll down a little bit. It's there, it's the formula sheet, okay? I'll try to remember to put this on the test, but I can't guarantee I will. But everything you need is there. So if you want to know, the formulas for parabolas, well, this is y squared form, and this is x squared form. And then if you want to know for circles and for ellipses and hyperbolas, they're all there. So just, this is your formula sheet. So you can take a picture of this, or you can download it, or whatever you need to do. Just know where it is. Content, course information, formula sheet. So this is the formula. How do I get p? How do I get this p value? Can someone tell me? Does anyone know? Is there anybody out there who knows how to get this? Well,
from the vertex to the directrix.
Yes, the vertex to the directrix. So we just go up. This distance is p. And so in this case, how far is that? Well, it's from -4 to 1. So 1, 2, 3, 4, 5. From -4 to 1. P must be 5. So more clearly, P equals 5. That means 4P, which is really what I care about, is 4 times 5, which is 20. So I have everything now. I'm actually done. I'm done the question. I just fill in my information. So x is always general, minus h, well that's minus -5, so plus 5 squared, equals 4p, so that's 20. And then y plus 4. I'm only missing one thing, and this is the same thing that some students missed on the assignment. What am I missing?
The negative.
Yes, the negative in front of p. And the reason that's negative is because it's facing down. And if it's facing down, you kind of need to add that yourself, okay? Like the equation doesn't necessarily give that to you. The reason we know is because from the directrix to the vertex, it's down. it's supposed to give us a negative, but most students don't catch that. So just be careful. The minus you have to put in yourself. And as a side note, I'm going to write down P is the distance from vertex to directrix, but also from vertex to focus. I could give either one, it doesn't matter. For example, for one section of this class, I gave the directrix. For the other section of the class, I gave the focus. It's the exact same thing. They both tell you the same information. So that's that. Okay, so that was why that assignment question worked out the way that it did. It's the exact same. I would like to move on to a different question, assuming that that's okay. I'd like to try, you can always tell me to go back. General equation of a circle, for example. Let's just quickly do that. We group the x and y terms. So group the x terms, group the y terms, and the constants on the other side. Take a common factor outside. Leave some space. Leave some space. And then I need to complete the square. How do I complete the square? Divide this number in the middle by 2 and square it. That gives 4 here. 2 times 4 is 8. Divide this number by 2 and square it. That gives 3 squared, so 9. 2 times 9 is 18. So we complete this. We keep going. 2. What does this give us? Now we need to divide this number by 2. X minus 2, all squared. Plus 2. Divide this number by 2. What does that give us? 3, all squared, equals 6 plus 8 plus 18. Well, that's a nice number, actually. It gives us 32. And then this is a circle, so what do I do next? There's one last step. What do I do if this is a circle? Well, I'm going to divide everything by this. Divide by 2, exactly. I don't divide by 32 because I don't want 1 on the right side for a circle. I want all the numbers in front of the squared terms to be 1. So divide everything by 2, and that gives me my final answer. Okay, now that's finished. So that's my general form. And now in order to get the center is pretty straightforward. The center, we can just read it off. It's 2 and negative 3. And the radius, well, this is my radius squared. And so it gives me 4. All right, that would be our final answer. That's how those work out. That's a pretty straightforward one. I wouldn't give you one a whole lot harder than that. All right, I'm going to keep going because I want to cover a lot. I didn't cover as much as I wanted to in my last class. This is all recorded if you need to go back. Given the equation of the ellipse, I know you know how to do that stuff. You should definitely know how to do that. Definitely know how to do that. All right, let's try 9 and 10. What is the equation of a hyperbola with the center at 0, 0, a vertex at 0, 4, center and vertex, two different things, and a focus at 0, negative 6. Okay, let's sketch it. Put down what we have. At 0, 0, we have our center. We have a vertex at 0, 4. 1, 2, 3, 4. That's our vertex, not the center. And a focus at 0, negative 6. 1, 2, 3, 4, 5, 6. That's my focus. That gives us a ton of information. Okay, that gives us a ton. How do we know that? Well, first of all, we're going to have to deal with a hyperbolic form. Is this going to be a y squared form, or sorry, y squared first or x squared first? Well, I'll tell you, if the vertex is up and down from the center, or the focus is up and down from the center, this is going to be y squared first. So what we need to fill in, we need to do this. It's supposed to be an x. Okay, that's y squared first form. That means our y squared term comes first in the hyperbola. And so we need H and K, which in this case are 0. Center here is definitely 0. 0, 0. So we don't need to write it in the formula. We just need a squared and b squared, and we're done. So try to put all your effort into finding a squared and b squared. Well, a is given directly. A is the distance from the center to the vertex. That's the definition. So a here must be, well, what is it? Well, the distance is 4. And so if a is 4, then what's a squared? A squared must be 16. So we have that already. We have a squared. All we need now is b squared, and we're done. The problem is we can't get b squared directly. We actually are only given information about c. How do I know that I was given information about c? Well, this is the vertex. This is the center. This is the focus. The distance from the center to the focus is c. So I'm actually going to take away the c there because it's confusing. So that's 1, 2, 3, 4, 5, 6. C is 6. That means c squared is 36. And if I have c squared and a squared, I can find b squared. All right? So I'm just, you got to puzzle it out a little bit, but you will get there. So we know that c squared is a squared plus b squared. That means I can find b squared. B squared must be b squared minus a squared. C squared is 36, a squared is 16. So subtract them, we get 20. And I'm done. So I know it seems very complicated at sometimes, but you have to do the practice. If you've only done like one of these, of course, it's going to be difficult. It's like listening to a song for the first time. Maybe you're like, oh yeah, good song, good song. Good job, Lady Gaga. But then, you know, you forget it after a day. But if you hear that song 20 times, then you're like, oh, I can sing it in my sleep now. That's the same thing as math. You need to be doing it. Watching me do it is almost useless if you don't practice it after or during, okay? Anyway, that's enough of my speech. Let's keep going. Let's fill in our numbers. We have y squared over 16 minus x squared over 20 equals 1. And I'm done. Done. All finished. Okay. Any questions on that one before I do a similar thing with the ellipse? This is your time to ask. Don't be afraid to ask questions. I'm sure that other people have the same ones. Okay. Y first? The y is coming first because the center, let me write it down. The center and vertex, I'll just say, are separated by a vertical distance. Or I'll say are separated up and down. What I mean by that, when we look at this diagram, you can see that the distance here is up and down, from the center to the vertex, up and down. If that's the case, that means our transverse axis, our main axis, is up and down. And so it's y squared first form. I know that because if I was to graph this whole thing, it would look like this. The center being at the middle here, and the vertex would be on this, okay? So there's a lot of little pieces, but I'm trying to give you the smallest piece you can get through. So if the center and the vertex are a distance up and down, or the center and the focus are up and down, then it's y squared first, or y first. If the vertex was sideways, you know, center was in the middle, and then the vertex was over, left or right, it would be x squared first. Is that okay? Okay. If you have any other questions, please let me know. That's why I'm here. There is 0% chance that I will finish all this review today. There are 7 different documents worth of questions. I'm just going to try to get through the ones that I think are nice to get out of the way right away. So let's take a look at this one. An ellipse has a vertices at 4 and 410. A focus at 4, 2. What is the equation of the ellipse? Okay, sketch it. If you sketch it, most of this is done for you. 1, 2, 3, 4, and 0. So that's a vertex. 4 and 10. 4 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's up high. Right away, my vertices give you the major axis. Okay? The vertices give you the major axis. That distance is 2b. So this distance here, what was the distance? It's 10. It's the major axis. Major axis is 10. Or in other words, the major axis. 2a is the length of the major axis. It's just part of the formulas. So it's 10. So that means a is 5, which also means a squared is 25. Okay? Let me summarize that. Just from the vertices alone, the distance between them is the major axis. So if we know the distance between them, that's 2a. That gives a squared. If we just divide it by 2 and then square it. Okay, the focus is at 4 and 2. 1, 2, 3, 4, and 1, 2. Okay, that's a little trickier. What are we going to do now? How are we going to find b squared or c squared? Well, let me try to make it clear for us. The center. Where's the center? How are we going to find the center? Clearly the x value is 4 because the center is somewhere in here. But how do we know where it is? Well, I'll tell you, because I don't know if you're going to answer me or not. It's at 5. Good job, Nasser. It's halfway between the vertices. Okay? So you just get the midpoint. So the center, or the y value of the center, you just take this and this. So 0 plus 10 divided by 2, it gives 5. So just a little extra information there. Of course, you don't need to write all that. But how do you get the center? You just go halfway. Look, one vertex, the other vertex. I can look at this directly and say the center must be in the middle. And so I have it. Now, what's B? Well, first of all, what's C? I can look at the diagram and figure out C. I know that my focus is at 2. I know my center is at 5. So C must be 3. How do I know that? The distance from the center to the focus. If I know C, then I can get C squared. Now, if I know C squared and A squared, I can get B squared. I know there's a lot of ideas floating around here, but we've done them all before. Okay, so I know that C squared is A squared minus B squared for ellipse. Yes, minus, not plus. Plus is for a hyperbola. That means if I'm looking for B squared, it must be A squared minus C squared. So B squared is 16. Now I have everything I need. By the way, my general formula was this. This was in the back of my head. I just realized I didn't say it. Now, this ellipse, is it going to be stretched vertically or stretched horizontally? Well, my vertices, my major axis is up and down. So it must look like this, which means that it's stretched vertically. That's where my A squared goes. That's where my major axis is. So let's fill in our information now. Center is at 4, 5. So minus 4 squared. B squared, what's B squared? 16. So y for the center is 5. B squared is 25 equals 1. So that would definitely be, if I was to ask that, it would definitely be a wrong answer. It wouldn't be a multiple choice. So let me recap. Your vertices give you the major axis. So your major axis gives you A. You have A, you have A squared. The center, once we find the center, we just look at the distance between the center and the focus. That gives C. And if you have A and C, you can get B, and you're actually done. All the rest is just a little bit of math in between. But as long as you understand the concept, you're okay. So let me just make a couple notes here. I'll go back. This distance is C, from the center to the vertex. Sorry, center to the focus. This distance is A, from the center to the vertices. Okay, anything I can clarify for this one? Again, I want to cover a lot of stuff. We're doing pretty good so far, but I don't want to go too fast. Okay, let's just assume that I can move on. If you want me to go scroll back up, I will. Let's identify these conics. This one should be a quick and easy one. It could be a multiple choice. I'm not saying that it is a multiple choice. I'm just saying it would be a nice multiple choice. Let's identify the conics. Well, I see a 2y squared. Well, first of all, I see 2 squareds and I see a negative. So as soon as I see a square, 2 squares and the negative between them, you should know that that's a hyperbola. Let's go on to the next one. I see a y squared and I see an x squared. There's a plus in between them and they have the same number in front. That's a circle. I'm looking at this and I'm seeing same number. So I see x squared, y squared. I see a plus. I see same constant in front. Those are my tricks for B. Okay, assuming you're still following, I'll keep going until I fall asleep. The next one, some students are like, well, I see a y squared and I see a minus x squared, so it must be a hyperbola. This is a bit of a tricky one because it's not exactly the case. If you bring the y over, this is what you'll see. You'll see 18x minus 12y plus y squared minus 4y squared is actually minus 3y squared. We'll bring that over. What we see here now is you have a negative 3 in front of the y squared. You have a negative 3 in front of the x squared. This actually makes it a circle because they have the same constant in front of both. You all still with me? It's pretty quiet out there in math space. But if you need me to slow down or repeat something, you just let me know. I'm trying to get through as much as I possibly can because I think the review is important. Any questions yet?
No, sir.
Okay, let's get to some more interesting problems. A road passes through a tunnel in a mountain. The walls of the tunnel are defined by a parabola with this equation, where both x and y are measured in meters. Well, I can see that this is a negative x form. So the tunnel looks like this. More or less, it looks similar to this anyway. And the formula is y equals x minus 8 minus x squared. And the question is, can a truck 3.5 meters wide and 4.5 meters high pass through this tunnel? So we're going to do something similar to what we did in the other word problems. Let's just think about this for a second. I want to think about this truck. We have a truck that would be 3.5 meters wide, and the height is 4.5 meters. The tunnel itself, basically, we need to put this truck inside, and we need to see, let's just say that the width is 3.5 across. What would be, we want to drive straight through, what would be half of that? 3.5 is the width if you drive straight down the center, but really what I really care about is this distance. Because if I have a point that far over, I can figure out what the height of the tunnel at that point is, and then I can figure out if it's going to be too big or not. So what is half of the width? Well, it's going to be 1.75. Okay, and that's the key to this problem. Are you with me so far? Hopefully so. So the real question I'm asking right here is, what is y when x is 1.75? So in other words, what is the height of the tunnel? Based on that equation, what is the height of the tunnel when x is 1.75? So let's put that into our formula. What is y when x is 1.75? If it's bigger than the tunnel, if the tunnel is bigger than the truck, higher, taller than the truck, then we're fine. If it's not, we have a problem. So let's solve this. This is 8 minus, well, I don't need to solve the whole thing. This is 8 minus 1.75 squared. This gives me 4.94 meters. Okay, now I'm going to ask you, that's not the final answer. The answer is, can a truck 4.5 meters high pass through this tunnel? What do you think? Anyone want to hazard a guess? I'm just writing out clear. So you're saying, yes, the truck can pass through the tunnel, and I'm agreeing with you because the height of the tunnel at that point is 4.94 meters. The truck is only 4.5 meters high, which is less. So really the answer is yes, the truck can pass through. Okay, so this is the style of problem you'll be expected to have to do on the test. It could be parabolas or ellipses. I'm not going to ask any others really. Maybe a simple circle. Okay, so I'd like to do more problems like this. I made up a worksheet yesterday that I didn't have time to post on D2L, but you'll be able to at least see it in this video, and I'll try to post it today, okay? I'm going to move on to that, and then I'm going to come back and try to do some examples on Unit 1 and 2. So just tell me if you need me to go over anything else. So you do not have this. It's not on D2L. You'll just have to work with me in a notebook or something similar until you get the file. Okay, so hopefully this will help you. I made this because I know what kind of questions you're going to have to do on the test, and I wanted to prepare you well. Okay, a train tunnel is in the shape of half an ellipse and 30 feet wide. All right, let's see what we have here. We have a 30 feet. This is trying to figure out how I want to write this. This is 30 feet wide, and the highest point of the tunnel is 18 feet above the ground. So this distance is 8 feet. And the question is, first of all, find an equation that describes the shape of the tunnel. Second part, we need to do something else. Well, let's get the equation first. So what do I know about this ellipse? Now, by the way, let's just write out the ellipse equation. If it's stretched horizontally, it's going to be this information. That's for an ellipse that looks like this. And this is half an ellipse, so it's good enough. What can I get from this? Well, I can easily get A and B, whether you believe me or not. Because look, this distance is 30. So the major axis is 30. What does that give us? It gives us 2A. And so if we have 2A equals 30, what's A? 15. And what's A squared? It's 15 squared, which is 225, I think. 225, yeah. So just by being given this small amount of information, I know the length of the major axis, which is the longest axis. Actually, in this case, this looks like the longest axis would be the other way. It would, yeah. This diagram is broken. Let's just go with it for now. The diagram is not accurate. Let me change one number, okay? Just so I don't break the full problem. Change this to 12, okay? Good. Just because I don't want to have to rewrite the whole question. So let's take a look at this. Now it's proper scale. So the major axis across is 30. Let's take a look at the minor axis. Can someone tell me the length of the minor axis or tell me what B is? Remember, B is from the center to the edge. So I'll just be clear here. I'm assuming that the center is at the center of the ellipse. What's B? Well, B is going to be 12. And the reason for that is from the center, yeah, it's 12, good job. The center to the covertex, or in this case, the center to the edge. You can see that that's given. Or in other words, you could say, 2B is 24 here, because it would go up 12, down 12, if we were to complete this. But it's easier just to think of it as 12. So if that's true, then B squared must be 144. And if that's the case, we have our full answer. Because the center here, I chose it to be at 0, 0. This center is at 0, 0. It's always a good idea to put your ellipse with the center at the center of it and make it 0, 0 because it makes your equation easier. Let's just take this and put our numbers in. Okay, so it's x squared over 225 plus y squared over 144. And that equals 1. So sorry about that mistake with the original question. I was using old old problems and changing numbers, and I made one that didn't make much sense, but not the end of the world. So we have this situation now, okay? We got our center, which we set at 0, 0. Our major and minor axis, hopefully it's clear why we got what we did. I mean, that's because this is 15. There's another way to look at it. And that gives us A squared. Our minor axis gives us B squared. Now we have our equation, but that's only part A. So let me try part B. Let's do it down here. Part B, we need to drive a train 16 feet wide through the center of the tunnel. What is the maximum possible height of the train? So I'm going to draw a similar diagram as I did before. I have this train. I know that it's 16 feet wide. I don't know the height, but I do know the shape of the ellipse. So if I was to drive that train, let me make another picture. This is my ellipse. and I want to put the train inside. Basically, I want the train to perfectly fit in. Now, that's not realistic. You wouldn't want to do that in real life, but it's important to know the maximum height of the train that can fit through. So if this is our situation, really what we need to figure out what the height is at this 8-meter point. Or in other words, what is y when x equals 8? The reason I ask that is, again, the train is going to go straight through the tunnel. Its width is 16, and so we need to use that information to be able to insert an x or a y point. We don't know the y point, so we've got to use x. So it drives straight through the center. It's 16 wide. Just get half of that. That gives us 8. And we can check that x value. We can check 8 and see what the height is based on the equation of the ellipse. And that'll be the maximum height we're allowed to drive through. So let's put this number in. Let's use our equation when x is 8. Okay, so we have 8 squared over 225 plus y squared over 144 equals 1. That will give us, if we solve this, that'll give us y squared. So x squared over 225, that gives us 0.284 plus y squared over 144 equals 1. I'm just going to skip to the final answer here. I'm going to find y squared. You can try this yourself. I'm going to take 1 minus 0.284, and then I'm going to multiply that by 144. It'll give me this. And then I'm going to square root it, just to have the space. Square root of that is 10.2 feet. Right? So that's the basic idea. You're going to get the equation first, and then you would put information into that to solve the question you've been asked. And I can really only ask two things. I either give you some sort of x value, where you solve for a y, or I can give you a y value, and solve for the x. There's really nothing else you could do for an ellipse. So is there anything I seriously confused you with here? I'm just going to move things over just a little bit. It all fits in. How do we feel about that? Let me move this down just for when you look at it later, it might make more sense. Any questions? Or are we just taking it all in? And assume you're just taking it all in. I'm going to move on to another question, okay? Let's do another question. Tell me if you need to go back. You're trying to design an elliptical running track, another ellipse. You want the inside area of the track to be 20 meters long. Okay, so the inside here is 20 meters. And you want it to be 12 meters wide. So this blue part is 12 meters. The track itself is 2 meters wide. That'll be important. That means that we have an extra 2 here, and an extra 2 here, and an extra 2 here, and an extra 2 there. That's really what that means. And then I'm going to say that the center is at the center because that makes life easy for us. Now we need to find the equation that represents the outside edge of the running track. And so this is an x squared stretched, horizontally stretched ellipse. So it'll have this form. So really all I need to get a squared and I need to get b squared. Because the center I know it's 0, 0. How do I get a? Well, a is the distance from the center to the vertex. And it says I need to represent the outside edge of the running track. And so really it's that bigger ellipse that I care about. So let me try to make this clear. The major axis, which in this case is the x, what's the length of the major axis? And be very careful when you answer this. What's the length of the biggest axis here? From the center to the very outside edge. the whole diameter. Well, what I see is I see a 20 and a 2 on either side. So really I have 20 plus 2 plus 2, or plus 2 twice. So that's 24. So I got a 27, and I got a 6. I got all sorts of things. I'm getting questions in here. I got to close this. It's 24, because it's 2 plus 20 plus 2 on either side, right? So that gives us that 2a equals 24. That means that a equals 12. And that means a squared equals 144. That's how we work that out. Again, the major axis is the length from there to there. The minor axis is the smaller axis. That means, let's give you one more chance to do this. What's the total length of the minor axis? From top to bottom. 16. Okay, now you're catching on. Good. 12. We add 2 for the top and 2 for the bottom. Of course, you could just add 4 if you wanted to, or you could write it directly, 16. But I like to show everything. That means 2b is 16, which means b is 8, which means b squared is 64. So that's how these work out. We're actually done. We have a now and we have b. We just need to write it in. X squared is 144 plus y squared over 64 equals 1. And we're done. Expression's finished. So that's one type of word problem, right? There's all the ideas are sort of coming together. You need to know what it means to have a length of a major axis. And really, it just means 2a. So figure out what that is. If you have a minor axis, figure out 2b. Divide that out and square out. And in the previous problem, we had more concern about, or earlier we had concern about foci. Remember that that gives us our c value. Okay? So I'll keep that there, or at least you can go back in the video, but I want to keep covering as much as I can. I'm going to move on to the next question. I'll try this one. So you're at the opening entrance to a giant parabolic room. So you're here, basically. You're down there. Made for testing reflection of sound waves. The curved wall is 80 feet away from the center of the opening. So what we have is this. We have a distance of 80. So this distance is 80 feet. And the opening is 150 feet across. So this distance is 150. The diagram is top down, so we're looking down on this, which means you'd be standing there and you'd look forward to the room. Find the equation of the curved wall. Well, what do I know about this? I know that my center, or this is the point 0, 0. We don't really have a center for a parabola, but it's good to note it. And we have a vertex up here. What's this vertex? Well, it's at 0, but it's going up by 80. So we have the vertex. This is a parabola. What are the two things we need? We need a vertex. We have it now. And the second thing you need, hopefully you remember, is P, or more specifically, we need 4P. How are we going to get that? Well, thankfully, this is pretty simple. We can see that this is x squared form. And I actually can see that it's going to be negative P as well, but x squared form is the most important part. So an x squared form parabola looks like this. I'm going to put in all the information that I know and solve for 4P. So first of all, I'm going to put in my vertex. I'll write this out. I'm going to substitute in vertex, and I'm going to substitute another point. I need another point. How am I going to get that other point? Does anyone remember? I kind of do the same thing every single time. I've got this width of the room, so I actually have 2 more points. the A, yeah, similar to A, I can either use this point or this point. This point here is 75 and 0 because I know this is half of 150, so this is 75 feet. Okay, so for parabolas, often what you have, you'll have the width given, and just take half of it to be able to get a point on the parabola. So I'm going to sub in the vertex and the point 75 and 0. So let's go ahead and do that. X, what is it? It's 75. Minus h, that's the 0. So minus 0, I can just leave it like that. 4p is what I'm really looking for. And then y minus k. The y is 0, and the k is 80. We've done this before, so that's why I'm not explaining every single step. We've done this numerous times, probably 3 or 4 times already. So 75 squared is 5625. Or let me make it quicker. 4p equals 75 squared divided by negative 80. What's that? 75 squared divided by negative 80 is negative 70.3. That's my 4p. So now that I have 4p, I can put it into the equation. So my final answer here is x squared equals negative 70.3 y minus 80. Now there's a part B to this, but I guess this is really the most important part. So in summary, I needed the vertex and I needed 4p. The vertex was easy. As long as you set up where the center is, you just go and take it. In order to get 4p, we always do the same thing. Put in your vertex values, h and k, and then choose any point on the parabola for your other point. And I just chose this one right here. Put that in. You'll notice that I substituted those in. I guess this should have been red, just to be clear. Okay, and then I'm going to do part B. So part B, I don't have a lot of space for it, so I'll just do it over here. Where should you stand if you want to shoot a sound wave 60 feet perpendicular to the opening? So what that really means is, what is the x value when y is 60? And the reason that is what I'm looking for is because my room looks like this. I want to know how far I need to stand over here for this distance to be 60. So I'm looking for this. I know that this is 60 something, some x value, but the distance is going to be 60 feet. So basically, where do I need to shoot a sound wave so it reflects off 60 feet away? Because this room is about testing sound waves. Okay, all you need to do is substitute in that point. So substitute in y equals 60 into your equation. So x squared equals negative 70.3. That's 60 minus 80. That means x squared is negative 70.3, 60 minus 80, that's 20, 1406. Square root both sides, 37.5 meters is your final answer. Okay, so where should you stand if you want to shoot a sound wave 60 feet perpendicular to the opening? You should stand 37.5 meters away from where you started. So you'll see a pattern here. Normally, first step would be find the equation. Second step is use the equation to give you some useful information. Anything I can review on that? You should recognize this as basically the same as the questions we've been doing. Anybody? I feel like I've destroyed your souls. I wish I could make the math easier. All I can do is explain it to you as best I can. Okay, so assuming that you're all still alive out there and everything's okay, I'm going to move on. I'm not going to do this whole question. I'm just going to set it up for you, okay? So this last question is basically the same, just slightly different. The walls of a giant reservoir are in the shape of parabola. As you can see, the walls are 300 feet apart. Okay, so this is 300 and 60 feet high. So this is 60 high. The base of the reservoir has a thickness of 8 feet halfway between its walls. Okay, so this is 8. That distance is 8. Find an equation describing the base of the reservoir. Well, I know the general form. This is x squared form again. So it's going to look like this. And I'm going to say that my center, actually I should write the full thing just in case. I'm going to say my center is down here. My center is there. My vertex then is going to be at 0 and 8. Okay, that's my vertex. And I'm not going to do the full thing, but I will note that if we know this is 300, then we know half of it over here, like we always do. We know that this distance is going to be 150, and the height up is 60. Okay, so we have kind of everything we need now. We have our vertex, and we can find 4p because I've been given another point. Okay, same process as before. Try the rest. You can try the rest yourself. Okay, so I want to move on to other types of practice. Is there any questions? You're all very quiet. Am I just overwhelming you? Is this thing on? No questions. Okay. Again, I don't want to annoy you asking questions. Maybe you just want me to go, go, go. But that's just not how I roll, man. I want to make sure that if you have a question, you can ask it. I want you to feel comfortable. Let's start jumping around. So let's see, tests, unit 1. Okay, let me ask you, because there's 0 chance we're going to cover everything we need to cover. What would you rather start with? Would you rather start me do some review of unit 1 and do a little less of unit 2? Or do you want me to do a little bit of unit 2 and a little less of unit 1? Which one do you want me to start with, unit 1 or 2? Complex numbers or functions? Unit 1. Okay, I'm just going to go ahead and do unit 1 because it's the oldest, yeah? It's been a while. So I'll do a few of these questions, not all of them, but a few of them. And this is off this is off D2L. It's practice 1. So if you want to know exactly where, it's right on the front page. You just look and click the first link that I put there. It's right here, practice 1. They're all there, all these are in there. So let's look at this. You need to simplify this. I said j rules. So you just need to remember that j to the power of 1 is j squared is -1, j cubed is -j, and j to the power of 4 is our special 1. And this is the best one, really. That's our most important one. So if you wanted to solve something like this, you should break it into something that looks like this. And the reason I did this is because this first piece is a j with a power, which is a multiple of 4. What I mean by that, 72, 72 divided by 4 fits in evenly. 18. It's an even power, which means it's the exact same thing. I can keep that there, I guess. It's the exact same thing as j to the power of 4. That's how they work. They just repeat after a while. And so what we end up with, j to the power of 4 is the same as 1. J to the power of 3 is the same as negative j. So our final answer is -j. So that's just a quick recap of how these j's work. I want to do a lot more than that today. So let's go ahead. What is the polar form of -4 and 7j? I could be given as graph only. So just keep that in mind. I might only give you the graph. let's do this question. First of all, let's just say we had to make a sketch, and you'll be expected to know how to make a sketch. I would expect you'll be asked that on the test. So first of all, -4 and 7 goes up. It looks like this. That means that that's going to be our r, and our theta is going to look like this. So we need two things. We need r and we need theta. First thing r, second thing theta. What is r? R is always the first one squared times the second one squared. A squared plus b squared, and then all square rooted. 4 squared plus 7 squared. What does that give? 4 squared plus 7 squared is root 65. Okay, that one's done. Theta. What's theta? It's always tan inverse of the b over the a. So 7 over 4. And in this case, that gives 60.3 degrees. Now, my question for you is, am I done there, or do I need to do anything else? Excuse me. The answer is, I need to do more, because this is quadrant 2. What tan is always going to give me is the smallest possible answer, which is that reference angle. So what I need to do, that's giving me 60.3. I need to take 180 minus. You need to say 180 minus that reference angle. Careful, Ayesha, it's not 60 minus, it's 180 minus. You take the full turn, and you'll subtract the small piece that the tan gave you. So you need to say 180 minus. So again, 180 minus this is our real answer. So 180 minus that is 119.7 degrees. And so the polar form, remember that polar form is our angle theta. So it's root 65, 119.7 degrees. Or, this is a perfectly acceptable answer, or its full form, its proper form, which is this. And you need to know that they mean the same thing. Okay, they are exactly the same. You can give me either one. They mean the same thing. They would get the same amount of marks. Okay, so please, please, please know how to do this. If you don't, then you might lose some marks on the test. Let me just say that. Okay, maybe you should know how to do this. Are you listening? Okay. Let's keep going. Simplify this. Well, I'll simplify a little harder one a little later. Let's keep going. Conjugate. If you had this, remember that I'm not going to do this whole question, but let's just say you were given it. You would start like this. Conjugate means to change the complex part of the denominator to a plus. And that would delete all the j's. That would make it into a number without j's on bottom. And remember, it's all about this minus and all about this plus. That's what conjugate does. It changes the sign in the middle, and it will delete all the j's on bottom. I'm not going to do the whole thing. I just wanted to remind you that's how you do it. There's more important questions. 6 was on your assignment. Let's try changing this to rectangular form. Okay, let's start. First of all, we have r given. What is it? What's r for this? Do you remember? Well, this is in polar form, which means it's r e to the j theta. So whatever isn't the j is the theta. So yeah, r is 5 here. Theta here is actually really strange. It's 2 pi over 3. That's in radians. In order to get from radians to degrees, you need to know you need to multiply by what? Well, something over pi, because you need to delete the pi, or you need to just delete the radians. It's always 180. 180 is our conversion factor. So in order to change from radians to degrees, this is what we do. So it's 2, there's 180 over 3. It gives 120. Now it's in degrees. Why did I want degrees? Well, because I want it in polar form, which then makes it really easy to get to rectangular form. So polar form, if you forget. Polar form looks like this. And I'm going to write the full method. Full form, that's our full form. So let's fill that in. It's 5 cosine 120 plus j sine of 120 degrees. All right, and in order to get the rectangular form, we just expand. We just multiply, multiply, open the brackets. So that's the same as this. So what's 5 cosine 120? Well, if you take 5 and multiply it by cosine of 120, you'll get, hopefully you get this, negative 5 over 2. And if you multiply 5 by sine of 120, you get this, uglier answer, but no less correct. And then we would be finished. So remember that if you want to do it in letter form, the first one here is always a cosine theta. Sorry, a is r cosine theta. That's how we get this. B is our sine theta. Okay, so different ways to get the same thing. And our final answer here is, of course, rectangular form. Rectangular form. I'm writing quickly so I can get as much time as possible. Okay. So that's how you get to rectangular form from exponential. Go through polar form is the easiest way. The next one, it says change what you've been given to exponential form. I'll do one more quick example of this, okay? Let's do it fast. Make a sketch. Left and up. Angle is going to be this. What is our radius? Well, first of all, how did I know the sketch? Well, it's because I know this must go over by 8. It must go up by 6. That much I know. How do I get it to correct form? Go to polar form first. 8 squared plus 6 squared. It's going to look a lot like I did before. 10. Theta. What's theta? It's going to be tan inverse of the 6 over the 8. And I'm going to have the same situation as before. It's going to be 36.9 degrees. But in this case, okay, you got a two-step process. Which quadrant is it in? It's in quadrant 2, which means I have the same problem as before. So you need to say, I'm going to change this. You have 180 minus the reference angle you were given. What's 180 minus that? It is 143.1 degrees. And then, because I need exponential form, I need to change that to radians. How do I change that to radians? Multiply by pi over 180 this time, because I need to delete the degrees. The degrees need to be canceled. And now I have what I need. So multiply by pi over 180 gives me 2.5 radians. Once again, why did I need radians? Because exponential form takes radians. What is exponential form? Exponential form looks like this. R e to the power of j theta, and theta's in radians. So just put in what you have. You have 10 e, you know the radians are 2.5, and then you stick the j on it, and we're done. This is our final answer, okay? So it would be really important for you to know how to do these. These would be a good question for a test, for example. Okay, so make sure you know how to know how to do these. Then we move on to 9. You can always look back on this video if you need to. I'll post it online today. Perform the indicated operations. I'll keep that there just in case you didn't finish. Perform the indicated operations. Then change your answer to rectangular form. Use 2 decimal places. So I need to do multiply and division, and then I need to change from polar to rectangular. So first things first. When you have multiplying polar form, the r's multiply and the thetas add. When you have division, the r's divide, the thetas subtract. Let's do that. I'm going to do the top first. Okay? The top. What's 12 times 8? 12 times 8 is 96. What is 238 plus 122? It's 360. I'm going to keep it like it is, even though that's a bit special case. What's 4 and 3 multiplied? 3 times 4. Well, that's 12. What's 57 plus 33? That's 90. And now I need to divide these two. What's 96 divided by 12? It's 8. And then 360 minus 90, what's that? It's 270. And then that's done. That's polar form. So the first part I've finished. The second step is I want polar form. Wait, sorry, I want rectangular form. So take 8 multiplied by cosine of 270, 8 multiplied by sine of 270. So that's a quick change, very fast, very good for a multiple choice. That'll be 0, and then 8 times sine of 270, negative 8j. Or you could just, of course, write negative 8j. It means the same thing. Okay? So I'm trying to get as many of these questions done as I can. I'm not going to get through all of them. I'm not going to get through every type. I'm sorry, it's not possible, especially not in Ramadan, but I'm doing as many as I can. So if I need to go back, let me know. Otherwise, you can see the YouTube video. Okay, 10, De Moivre's theorem. We covered that on the assignment. There's plenty of practice on that already. I'm going to move on from that. It's actually quite easy if you know the steps. So just make sure you know how to do that one, okay? I'm going to move on to a different type. So in the second review, complex numbers practice. Again, this is just changing the form. This is just knowing that the square root of -1 is j. You know how to do that, it's quite simple. The third one again, use conjugate. The fourth one, again, you just really need to know that and multiply. This one we did on the first assignment, isolating x. This one, changing to polar and then to exponential. We actually did one just like that. We should definitely know how to do that. This next one, represent the following complex number graphically and give its rectangular form. Let's do that one quickly. This is in polar form. What is it in rectangular form? Well, 4.7 cosine of 300 is 2.35. And then 4.7 sine of 300 is minus 4.2. Okay, let's just draw a random axis here just to have something to work with. And let's graph this. 2.35 to the right is about right here. -4, 1, 2, 3, 4 is about right here. And so I'm just going to draw my vector. And that's it. That is 2.35 minus 4.072. Okay? I could ask you to graph it like that, or more likely, I'll ask you to take it and then tell me what the form is. So I'll just give you an arrow, and you give me, as a multiple choice, for example, what the number is. You know, is it 2.35 minus 407? Is it 2.35 plus 407? What is it? Okay. Multiplying in polar form and then change it to rectangular form. We just did that. So remember, you multiply the first ones together and you add the angles together. So for example, let me do it quickly because that sounds fast. This would be 15 root 2 times 3 root 2 is 30. 74 plus 16, what's that? 74 plus 16, ooh, a nice 90. So cos 90 plus j sine 90. And then it wants rectangular form, which just means open it. What's 30 cos of 90? That's 0. What's 30 sine of 90? That's 30. So really the final answer is 30j. That'll be a nice multiple choice because they don't actually take that much work. And again, if you ever need me to stop or slow down, go over it again, I will. I'm trying to get as much time to it. Okay. De Moivre's theorem, again, we did for assignment 1. I'm not going to review that. Change to polar and then rectangular form. We already did that. Multiply and then change the form. We did multiplication and we did change the form, but I'll just quickly show you. In its exponential form, it's the exact same thing. What's 8 times 5.5? 44. What's these added together? 5.3 plus 0.77. It's 6.07j. j. And now I need it in polar form. Well, polar form's easy. Just change your theta times 180 over radians. So times 180 divided by pi gives 347.8 degrees. And this is my polar form, 44 angle 347.8. Because I changed my degrees, and that's the only difference between polar form and exponential form. So this is polar form now. If I want it in rectangular form, I just multiply by cosine of the angle and multiply by sine of the angle. So 44 cosine 347.8 gives me 43. And then what else do I have? I have 43, and then 44 times sine of the angle is negative 9.3 j. That's my rectangular form. Okay, sorry, a little bit messy, but I'm trying to do as much as I can. Okay, quick and dirty. And that's the end of this particular section. I want to move on to some functions work. And if you don't tell me to stop, I'm not going to stop. So let's keep on going. Let's see here. Let's take a look at the review for functions. Okay, this particular practice is this one, Unit 1 and 2 review. And I'm doing page 6 of that. Unit 2 functions. Determine whether or not they represent functions. Do they represent functions? The first one, vertical line test. Yes. And I'm also going to add in, I want you to be able to do domain and range. If you can't do domain and range, you've got a big issue, okay? You need to be able to do it. So let's do domain. What's the domain of this? Are there any x values this is not allowed to be? Well, it looks like it goes off left and right forever, and everything in the center looks okay. So the domain is all real numbers. There's no problem. The range. What's the range of this? Well, again, there are no bad numbers, and it goes off in both directions forever. So here, it's all real numbers. Okay? Please interject if you need me to answer something for you. Like if you don't understand what domain and range means, you're going to want to ask me. Okay, B. Is it a function? Well, if I do the vertical line test, it touches twice. So definitely not. It's not a function. But it still has a domain and range. What's the domain? Well, what's the range? Well, the domain here are all the possible x values. So the smallest possible x value is down here. The biggest possible is around here. That's about 1, 2, 3, about 3.5. So x is smaller than 3.5 and bigger than negative 3.5. I kind of ran out of space there. The range, the biggest is 5, we'll say, and the smallest is negative 5. So range needs to be between 5 and negative 5. That's our range. It can be any y value in between those, but it doesn't exist bigger or smaller than those. Let's look at this one. Is this a function? Yes, it is, because it always passes the vertical line test. And I'm not going to ask you to do the domain and range of the piecewise. This is a piecewise function. I'm not going to ask you to do domain and range. All right? Is this a function? 2 maps to 1, 3 maps to 2. The problem here is 2 maps to 1 and 4. It's not a function. If all the x values only had unique y values, we would okay. But there's a problem here. X maps to 2 things is bad. Composite functions. I think you're all okay with this, so I'm not going to review it. This is pretty simple. You should be able to do all of these, including this. This is where some students get really tripped up, okay? Stating the domain and range for the functions. So I'm going to give you a giant tip. You should absolutely 100%, 1,000,000% graph these. Okay, I'm just bringing up a couple of little solutions for myself here. But if you don't graph them, you're kind of making your life way more difficult. So graph it on your phone or graph it on your computer, graph it any way you can. I've been doing this all term. I've been telling you to do it. So it shouldn't come as much of a surprise that it would be something you want to do on a test. Just look at it. 2x minus 3, square it, add 4. I can easily tell now what the domain and range are. The domain is at all the possible x values. Well, this function doesn't have anything that's wrong with it. You're allowed to have any x value. I could say, what's the x value at 3? What's the x value at 0? What's the x value anywhere? They're fine. So it's all real numbers. The range, although, is different. The range, it looks like it has to be 4 or bigger. So the range, all the possible y values, nothing exists below 4. So we say the range is greater than or equal to 0. And that's it. Not 0, sorry, 4. Greater than or equal to 4. Because look, everywhere below that line, there's no y values. So y equals 3 does not exist. Y equals 2 doesn't exist. Y equals 1 doesn't exist. Y equals 0 doesn't exist. None of them exist. Y equals 4 is okay. Y equals 5 would be okay. But anything below that doesn't exist. So we had to say it's not part of the range. Let's try the next one. I'll graph it, like you should. Fraction. So you put in square root. You can find it in the calculator below. This is the fastest way to get this. Hey, that looks weird, but it's easy when you see the graph. What's our range and the domain? Well, the domain are all the possible x values. It looks like it needs to be 7 or bigger. So x needs to be greater than or equal to 7. The range here, it doesn't exist below 0, so the range must be everything greater than or equal to 0. Okay? So for the domain and range, I'll generally give you the graph, and you need to give me back the domain and range. It'll be a multiple choice probably. All right? So just be prepared to be able to do these. I'm trying to set you up for success, but if you're not trying to graph them as I suggest, you're going to have to do it by hand, which we have done, but it takes a lot longer. So try to work smarter, not harder. Let's see what else I can find for you that I want to review. Aha, this will be a good question to review. For the piecewise function, let's evaluate these. All right, let's say we have the first function, let's call it function 1, and call this function 2. The first one, first case, -1. Which function does that belong to? The first one or the second one? When x is -1, well, that's less than 2. So it must be the first, that must be the first one that we would use. So let's put in -1 into the first function. 1 over 2, it's -1 plus 4. So if we work that out, we get 3 over 2 or 1. For the next one, 2. Which function has 2 in it? Well, we can see here, it's less than or equal to 2. Is it time to go? Or is everyone leaving? I feel like everyone's leaving early. We have 3 minutes left. See you, everybody. We're going to use this first function on this one. That would be 1 over 2. Put in a 2 plus 4. It's 3. For the third one here, you're going to use the second function because it's 4. This 4 is between 2 and 5. And so we put it in. Put in 4, square it, minus 5, multiply by 4, add 10, and so on. So that's 4 squared minus 5 times 4 plus 10. It's 6. And so on. So I'm just trying to prepare you for different types of questions. I can't get to every single one. There are too many different types to cover. But I'm trying to touch on a little bit of everything. And hopefully it's helpful to see these things again. But there's a ton of content, as you can see. You'll have to know how to do changing transforming points. So this will, maybe I'll do this one. This will be the last one I do. Now I want to give you a little bit of advice. So if 3, 4 is a point on the graph of y equals f of x, state the coordinates of the point after the transformation of y minus 5 and x plus 6. But we have two things going on here. The y minus 5 means we shift up by 5. The x plus 6 means we shift left by 6 because it's always opposites. So what that gives us, we have the original point 3 and 4. Well, we need to shift it up by 5, so we need to add 5 to this one. And we need to shift it left 6, so we need to subtract 6 from the x part. And then we get our answer. 3 minus 6 is negative 3. 4 plus 5 is 9. And so you can get the answer that way. And again, there's tons of other questions I could cover, but I just tried to cover as many different ones as I could. I'm going to stop the recording here and then, okay, bye-bye, everybody. Good job. Good luck studying.